So he said, while we have the short-term political problems of how we would deal with a defense system, who would build it, who could be trusted to control it, on the long term, we are going to have to deal with this problem. So let me just read this from his book, Pale Blue Dot. Since hazards from asteroids and comets must apply to inhabited planets all over the galaxy, if there are such, then intelligent beings everywhere will have to unify their home worlds politically, leave their planets, and move small nearby worlds around. Their eventual choice, as ours, is spaceflight or extinction. Let me now give you a quiz. I really am curious because I've explained how impacts are part of the natural process of evolution. If it had not been for the impact 65 million years ago, we would not be here. Or maybe we could be something like this, but the building would be shaped differently and the seats would be much larger because you and I would all be dinosaurs, intelligent dinosaurs. The dinosaurs were doing just great up until that impact. They were not in decline. They ruled the world. They'd ruled the world for 100 million years. And yet, in a moment, they were wiped out by an impact. And if it hadn't been for that, we wouldn't be here. It's a really important part of the evolutionary history of the Earth. Now, I'm telling you, and Carl Sagan was advocating, that we might want to get the technology to stop this from happening again, to interfere with the natural process of evolution. So I want to see a show of hands. How many think that is morally and ethically acceptable for us to interfere in one of the most fundamental aspects of evolution so that it won't happen again? Show of hands. All right. Now, not everybody put their hand up, so maybe there are some others. How many think it is morally and ethically questionable for us to defend ourselves against an asteroid that could cause an extinction? A few. I should talk to you guys later. In fact, there are more here who think it's ethically unacceptable than is usual when I give these lectures. I'm with Sagan. I think humanity is worth saving. And I think that, in fact, we are not outside of the process of evolution. We are a part of evolution. If evolution has produced a being smart enough to recognize the danger, to carry out a survey, to build a spacecraft that could deflect an asteroid, then that is not contrary to evolution. That is, in fact, just an extension of this process. But I recognize that there is a legitimate difference of opinion on that. I will give you that as something to think about when you go home. And think about also the fact that the astronomers who for the last 10 years have been carrying out this survey have, in a sense, been making you safer. 3/4 of the asteroids that pose the greatest risk have now been discovered, cataloged, their orbits calculated, and have been shown that they will not hit. So the chances of you being hit by an unknown asteroid in that size range today, that is, of the Earth being hit, is only about 1/4 what it was a decade ago. So in this sense, astronomers are saving the world. Thank you. And I would, of course, be delighted to answer questions.
Thank you, David. Thank you so much, Dr. Morrison. A terrific lecture. And we do, as you heard, have the opportunity to ask some brief and to-the-point questions. There are 2 microphones set up in the middle of the auditorium. You see that there's a space between the upper section and the lower section. What we ask, if you have a question, is that you line up in front of the microphones. And I'm going to ask Dr. Morrison to take turns, one microphone to the other. If you're not able to stay, we are very glad you were able to come. Take the sheets on your way out, and we hope to see you November 14th. But for most of you, I'm now delighted to invite Dr. Morrison to take questions.
I can't see very well.
Either of us.
Right there. Start with you.
Is this on? This on? I wonder if you have considered the possibility of larger asteroids that are not near the Earth, maybe with more eccentric orbits.
Yeah, they're called comets. And I very carefully did not talk about comets. Fortunately, asteroids constitute most of the risk, something between 95 and 99%. But none of this works for comets. A survey would not pick up a comet decades in advance because they come in from deep space. We could not calculate a comet's orbit precisely enough to know if it would hit or not. We wouldn't know whether to try to deflect it because we might just as well deflect it into the Earth as away from the Earth. And it is definitely not within current technology. So if you want to worry tonight, worry about comets. Maybe our grandchildren can solve that problem. I'm only dealing with asteroids. And I know we're never going to find the last asteroid either. This is a risk reduction program. But there's no free lunch. There is no way to absolutely make the Earth safe from impacts.
Yes, thank you. I was under the impression that the extinction at the KT boundary took about 1 million years, as you mentioned, but you're also saying that the extinctions took 20 minutes. Can you maybe speak to what evidence has led to that change?
Well, yes, the question, of course, is not the definition of the KT boundary, which is that little thin layer which is beautifully documented by the microscopic creatures above and below, and that is effectively instantaneous. The question is the big creatures like dinosaurs, for which there are many, many fewer fossils. There are more fossils of these foraminifera in a thimbleful than the whole Earth's fossil collection of dinosaurs. You know, something like 35 T-Rexes in the whole world, and they're spread over a depth in time of 50 or 100 million years. So you cannot easily tell when the last dinosaur lived. And the same thing's true for a lot of other creatures. So if you want to see whether the extinction was instantaneous or not, you have to do some careful statistics, which is what paleontologists have been doing in the last 10 or 15 years. Collecting more samples, trying to very carefully date or position the ones they see, and then apply some moderately sophisticated statistical tests to see if they're consistent with instantaneous death or a gradual decline. And in the case of the dinosaurs and the other creatures at the KT, they essentially all come out as consistent with instantaneous.
Thank you.
Well, all through this lecture, you were talking about how the asteroids sometimes hit the Earth, of course. And, well, isn't it possible that the Earth might sometimes hit the asteroid?
Right.
I'm just saying.
It's absolutely possible. In fact, there's no difference. The two hit each other. But we only try to deflect the asteroid. It is 1 billion times easier to move the asteroid away from the Earth than to move the Earth away from the asteroid. But you're absolutely right. It's the two hitting each other, and the energy is of their mutual collision.
Hello. I have 2 questions, so I'll start with one. Would it be possible to, because you said the asteroids that would be being deflected are considerably smaller than Earth, about 15 kilometers long, to merely kind of break them up and make it so that there were many more smaller asteroids closer to the Hiroshima impact than there was one large one?
Mm-hmm. Yes, and whether that is a good idea or not depends entirely on when you do it. If you do it like they did in the movie Deep Impact, at the last minute, 2 days or 1 day before the impact, all the fragments will still hit you and you haven't helped at all. It's the same amount of energy. It's like going from a cannonball to a buckshot, and it still would do the damage. If you can disperse it millions of miles away on some previous orbit and break it apart and have the pieces move away, so that maybe only 1 or 2 of the pieces hit you, then that would be a perfectly good thing to do.